Okay, so moving on to Cifar. Cifar is another extremely common data set. It still is used as a benchmark. So it is a bunch of little tiny color images, and they're a little bit bigger. They are 32 by 32 by 3. This is channels, right? They're color, so it's RGB. 32 rows, 32 pixels per row, 3 channels per pixel, right? An R, a G, and a B value. Each image is assigned one of either 10 class labels in the Cifar 10 dataset, or one of 100 class labels in the Cifar 100 dataset. So it is the same images, they are given finer labels. In the Cifar 10, the labels are things like animal or vehicle, right? In Cifar 100, it's bear, dog, cat, duck, right? So it's finer, you see? Instead of just being animal, it's one of 10 specific kinds of animal, right? So Cifar is a little bit easier to get ourselves than MNIST was going to be, because it's just a pickled Python object that you can download. If you haven't heard of it before, pickle is an object persistence format. And that's fairly easy to do, but we can also just get Cifar from TFDS. And since we've already done that, we'll do that again. And I'll show you the demo code in a minute. Nothing much changes. It's not very different. But Cifar is more challenging than MNIST, especially Cifar 100, right? They're bigger, they have more input, they have not been scaled or centered, right? The object in the picture could be sort of different sizes at different places, right? And the category labels are much finer. But performance on these is still getting pretty good. The same aggregator I found showed a best result of 96.53% accuracy for Cifar 10 and 75% for Cifar 100, right? So Cifar 10, I think I can say, is getting close to being solved by the same definition I used before. Cifar 100 still has a ways to go, and so is still an interesting benchmark, right? Because it's more complicated, though, you need to use larger, much more sophisticated networks, right? You can't get away with 3 dense layers and expect to see any kind of decent performance. You're going to have to use a much deeper, much more sophisticated architecture. All right? And we haven't talked about those. We'll talk about those later, right? We'll talk about the kind of network that can potentially train well on Cifar later. But here is our Cifar code, right? And again, we didn't really train much, or change much, right? I just changed MNIST to Cifar 10. I have pretty much the same processing. And let's just go ahead and do this that way. We can just delete that for the time being. And should have looked at this before I threw it up. There we go. Sparse categorical cross entropy. 10 epochs. Again, let's see if my video recorder holds out. And again, the first time you do this, you're going to see it download the data set, so it will just kind of do nothing for a minute. It will appear to do nothing because we disabled the progress bar. Just give it time. Give it a little bit. I believe Cifar is bigger than MNIST, although I don't think it's huge. Oh, gosh. I'd have to look at the website to remind myself of how big it actually is. I think it's also on the scale of hundreds of megabytes. I'm not going to swear to that. So what we're going to see, what I expect to see, yeah, there we go. So loss on our first iteration is 2, which is pretty bad, right? We would sort of... So interpreting categorical cross-entropy losses is a little bit tricky, but basically that means it's fairly off, right? It's wrong category a lot of the time. that pauses it running the test set. Alright, so we notice the loss has gone down, but the value loss, maybe not quite as much, right? So loss went down a bit, value loss not quite as much. And that time, the value loss actually went up slightly. I'll go ahead and spoil it for you, even though we're kind of watching this, and it occurs to me that if you're on the YouTube, then being asked to stare at this little corner of the screen is probably not super exciting, right? But as many of you may have already guessed, right, this is not going to work. This network is too small and too stupid to do a decent job of learning Cifar 10, right? And that's even just Cifar 10, not Cifar 100. We would have to be noticeably smarter to expect to see decent performance here. I expect our value loss to not be stable and to go up at some point, but we'll see. Yep, again, went down, went up. So, as we see, right, again, as we see, our loss is stepping down incrementally, our value loss is going up and down, right? Point adequately belabored, this little network is not going to learn this data set. I'm a little bit leery of trying to do it at the same time that I'm trying to record the lecture, but we could go ahead and add another layer here and see what that does. But what you're going to quickly run into is catastrophic overfitting, right? We're going to get, well, first off, obviously it is significantly slower, but second, we're going to get so many parameters that we're going to have a problem with catastrophic overfitting. And that's going to be equally tricky to solve, right? So, yeah, Cifar is a significantly harder problem that requires us to be much more sophisticated in our network design. I want to see what our first epoch gets us. Boink. It's all right. So the first time through test or training loss was almost 2. Value was almost 1.8. This is also why you start to want GPU acceleration. This thing is a first-gen Ryzen 7, and it's still not exactly soaring through this, especially not when it's doing a video record at the same time. But we're going to get our value loss. Yep, all right. So our value loss did step down. I wager that if we left this running for a while, we would see that value loss fluctuate a lot more as the training set approaches 0. I'm not going to sit here and watch that in silence for 10 more runs. Okay. So that is MNIST and Cifar, and now we're going to talk about loading our own data.